Now we're going to learn about an algorithm that can use the idea of finding a flow augmenting path and use that to increase the flow until we find a maximum flow. Here's the idea of the flow augmentation algorithm. First, we begin with any flow. Number two, we find a flow augmenting path and increase the flow along the path. Number three, we repeat step number two until it's no longer possible to find a flow augmenting path. Let's take a look at this example here. Currently, there is no directed path from A to E where we can increase the flow. So notice that if we go from A through C and arriving at E, this edge here it's already at maximum capacity. The flow there is equal to the capacity, so there is no more room to improvement there. If we go from A through B, notice that this arc here, it's also at maximum capacity. And if we try to go through this edge, through this arc, then it's also at full capacity. And it seems like there's nothing else we can do to increase the flow. However, one thing we can do is to look at the edges or the arcs that are going into the reverse direction. For example, there is no directed path from A to E that will allow us to increase the flow. But we can, if we ignore the arrows, if we ignore the directions, we can use a path going from A to C to B to D and to E. Along this path here, notice that there is an arc going into the opposite direction. Perhaps we can decrease the flow here. Instead of increasing the flow, we can decrease the flow along the reversed edges, the reversed arcs. And that's the idea that we're going to use. There is a path from A to E, as we can see here, where we can increase the flow. And the idea here is to send 4 units from C to B. But how can we do that if this edge is reversed? One way to send 4 units from here to here is to simply decrease the flow going from B to C. So we increase 4 units of flow along this edge, and those 4 units, they cannot go this way, but they can go this way by subtracting 4 from the current flow there. So this way, this indicates that we're sending 4 additional units of flow from C to B. Those 4 units of flow arriving at B need to go out of B, and they can go through this arc here. So we increase the flow right there by 4 units. And then from this vertex, vertex D, we can increase the flow from there to vertex E, to the sink. So that is the path where we can increase the flow. This is not a directed path because this edge is going against the direction of the path. But if we ignore the arrows, then this is a path from, simply considering this as a graph. We can, along that path, we increase 4 units of flow. So here's step number 1 of the algorithm. We start by labeling the source with this label. Now this label has 3 entries. The first is the predecessor. Now because this is the source, there is no predecessor to the source, we simply write source, or you can use a dash, or you can leave it blank. Now the second entry of the label is the plus sign, meaning that we are able to increase the flow. Now the source, at the source, there is no limitation. We can increase by any number we want. However, the limitation will come as we go out of the source. going through the arcs because the arcs have capacities and they're limited. So, but at the source we put the plus sign. And infinity means that at the source I can increase by any amount. Anyway, that's the standard label that we used just to begin the algorithm. Now, step number 2, we are going to do something called the scanning and look for labeled vertices that are not scanned, and we choose the first one. So here we choose vertex A. So from vertex A, we now scan the vertex A by looking at all the adjacent vertices to A. So that will be B, C, and D. Now at each one of them, we'll do an action. Now there are several possibilities. One possibility is that along the arc going from A, arriving at the adjacent vertex, if the flow is equal to the capacity, then there's nothing we can do. We simply don't label that adjacent vertex. So here is B, and look at the arc there. The flow is equal to the capacity, so we don't do anything. Moving on to the next adjacent vertex, we find C. Now here is another possibility. Here the capacity is 8 and the flow is 0. So the flow is less than the capacity. In that case, we should be able to increase the flow along this arc. Now, how much flow we can bring from A to C? Well, the capacity here is 8. There's room for 8 units of flow. So we're going to label C with the label A, meaning that the predecessor is A, we're coming from A, plus, meaning that we are able to increase, to add, and 8 is the maximum flow we can increase along this arc from bringing from A to C. In other words, this label, when you look at this label, it tells you that from A, from the predecessor A, we should be able to increase up 8 units of flow, up to 8 units of flow. Now we look at the next adjacent vertex, and here again, flow is equal to the capacity. There's nothing we can do. We don't label vertex D. So we finished scanning A, vertex A. So we mark A as scanned with a star, with an asterisk, and we move on now back to the beginning of step 2. We select a vertex to scan. Now we select a vertex that it has not been scanned yet, but it has to be labeled. Label vertex that is not scanned. That means we're going to go to vertex C. At vertex C, we do the scanning. Scanning means that we look at all the adjacent vertices to C. That will be A, B, and E. However, A is already marked scan, so we don't do anything with A. That means we're going to look only at vertex B and E. Now here's a different possibility. When we look at vertex B, there is an edge from B to C. So it's a reverse edge because we are at C. When we look at this edge is going into the opposite direction. When that happens, then the only way to move flow out of C through this reversed edge is to decrease the flow that is already in there. So currently along that edge, there is 4 units of flow going into the opposite direction. One way to move flow out of C along this reversed edge is to simply decrease the flow here. And that's exactly what we're going to do. Now at vertex C, we have up to 8 units of flow that we should be able to increase up to this point. However, there is only room here to decrease 4 units. We can only decrease 4. This way the flow here will go down to 0. The number here cannot be negative, so we can only decrease 4 units. That means we're able to move 4 units, up to 4 units of flow along this reversed edge. That means we're going to label vertex B with this label here, predecessor C, meaning that we're coming from C. The negative meaning that we're going to decrease the flow along this arc. And 4, that's the maximum flow that we can bring along this edge. Bring 4 units of flow from C to B by decreasing the current flow. Next, we look at the next adjacent vertex, which is E. And again, here we've seen this before. Flow is equal to the capacity. There's nothing we can do here. Therefore, we don't label vertex E. We mark C as a scanned vertex. Now moving on to the next, back to the beginning of step 2, we go to the next labeled vertex. That will be vertex B. At vertex B, again, we do the scanning. When we scan B, we look at all the adjacent vertices. We have A, C, and D, but only the unmarked vertices. So A is done, C is done. So the only adjacent vertex that we can look would be D. So at D, we look at the edge, and currently there are 2 units of flow, and there is room up to 4 units. So we can move up to 4 units from B to D. And that's the maximum we can move, because this number here is telling us that we, from C, from the predecessor to B, we can increase 4 units of flow. So we only have 4 units of flow available to increase, and we have room for 4. And we're going to label D with the label B, meaning that's the predecessor to of D, plus meaning that we can increase the flow, and 4, that's the maximum flow we can increase along this edge. Now just one comment here. Let's say, for example, that this number right here at the label of B, suppose that number was 3, for some reason it was 3. Then even though we have 4 units of space, right, that we can increase the flow along this edge, we only have 3 units of flow at this point here that we can increase. So this is important. Even though we have room for 4, we can only bring as up to what this amount is telling us. That means that B is scanned. We're going to mark it with a star. We move on to the next labeled vertex. That's vertex D. We look at the adjacent vertex, E. Notice that this edge here from D to E, we have room for 4 units. So we can increase up to 4 units. But at D, we only have 4 units, so we should be able to increase all those 4 units along this edge. And we label vertex E with D plus and 4. So we mark D as scanned. And since we arrived at E, now we should be able to do step number 3. Step number 3, we're going to increase the flow because when we reach the sink with the label, then we should be able to increase the flow from the source up to the sink. Now it's important to look at this very last number, the 4 that we see here at the label of the vertex. That tells us how much flow we can increase. That number is the amount of flow we can increase by following the predecessor. So here we look at the predecessor D, should be able to add 4 to this edge here, to this arc. And we add 4 here, because from D we look at the predecessor and the plus, meaning that we're going to add. Now at B we look at the predecessor, that's C, and here's a negative sign, meaning that we're going to subtract 4 units. Not these 4 here, but the 4 there. Okay. This is important because if we have a different number here, we wouldn't use that number to decrease the flow. We only use the very last number. This is important. It's the very last number that counts. So we decrease 4 units there, and we add 4 units here. Even though I can bring up to 8 units of flow along this edge, but we only add 4 because that's the number here at the sink. So we do that, and the new network, the new flow is then reflected right here. So notice that this now is 4. Here the flow is 0. Here the flow is 6, and here is 9. So the algorithm allows us to increase the flow, or if there is no more room to increase the flow, then the algorithm will tell us that we reach the maximum flow. Now, if we apply the algorithm again, we will see that the sink will not be labeled. When the sink is not labeled at the end of the algorithm, that means that we arrived at a maximum flow.